In yesterday's class, we talked about counting principles. We also talked about addition and multiplication principles of counting. We now have applied basic counting. You say up to now, we talked about those problems that need only addition principle or multiplication principle. We either use addition principle or multiplication principle. But now we talk about some problems that if we have both in the same example, in the same problem, in solving the same problem, if we need to use both multiplication and addition principles in solving one problem. Here we talk about these. Talk about these problems. Here we have an example. It says how many 8-bit strings begin either 101 or 111, triple ones. How many 8-bit strings begin either 101 or triple ones? Here for 101, as you have 8-bit string, that means here we have only 3 bits. How many more we have? 5. That means we must have 5 more strings. Okay, as that's 8-bit strings. Here we have only 3. 101 is 3 strings, and we must have 5 more to get 8 strings. Okay, 8-bit strings. Here we just choose each string among 0 or 1. It's either 0 or 1. That means you have only 2 choices for each string. Okay, for this string we have 2 choices. That means it's 2. So here, as you choose, as you pick one from 2 things, that means you have 2 ways. We have 2 ways to choose this string. Here we have 3 strings, and we must have 5 more strings to get 8-bit string. Okay, for each string we have only 2 choices. That means there are 2 ways for choosing any string. For this one we have 2 ways for choosing it, because it's either 0 or 1. So here we have 2 multiplying by. For this one we also have 2 choices. It's either 0 or 1. It's either 0 or 1. For this one, we have 2 choices. This one and this one is 2. Look, as you see, here we have 5 2's which are multiplied to each other. And here you say 2 times 2 times 2 times 2 times 2 is 32. That means here there are 32 ways. There are 32 ways for those 8-bit strings which starts with 101. The rest could be written in 32 ways. I mean the rest 5 strings could be written in 32 ways, because for each string we have 2 choices. It's either 0 or 1. It's either 0 or 1. Okay, ليه الكمبيوتر تنها صفر يا اخوانات بهاشتاج. اوكي، صفر يا ذات لينيا هاشتاج دي صفر يعني ليه بو ام سترينجيرا شو الاختيار معناها دو يا صفر يعني يك اي بوما دو يا صفر يعني يك بوما يا صفر بهماش. Since you have successive tasks, this is T1, this is T2, this is T3 up to T5. Since you have successive tasks, that means we must use multiplication principle. Here in this case we use multiplication principle. That means for each task we have 2 choices, and multiplying them we get 2, which multiplied 5 times by itself, and we get 32. That's for those strings which begins with 101. So how about those which begins with 111? Triple ones. It's the same. Since here we have 5 successive tasks for T1, T2, T3, T4, and T5. For T1, we have 2 choices. It's either 0 or 1. That means we have 2. Since we have successive tasks, so we multiply them times 2, times 2, times 2, times 2. So we get 2 multiplied by itself 5 times, and we get 32 here also. But in the question, it says, how many 8-bit strings begin with either this or that? That means we are going to find the sum of both. Okay? Here we have 2 different tasks. The first one starts with 101, and the second one starts with triple ones. That means here we have 2 different tasks. So for finding the total way here, we just find the sum of totals, the ways here, the number of ways here, which starts with these. For this one, we say we have 32 ways, and here we have 32 ways. 32 plus 32 is 64. So you say 32 plus 32 is 64. As you see here, we use both multiplication and addition principles. We use both addition and multiplication principles. Here, we use multiplication, and then we use addition. We use both addition and multiplication principles for solving this problem. Okay? Now we have another example. It says the following items are available for breakfast. We have 3 types of cereal, 4 types of juices, and 6 types of breads. In the question, it says how many ways a breakfast can be prepared if exactly 2 items are selected from 2 different groups. That means here we just can pick 2 items from 2 different groups. For example, one from this, one from this. Okay? Or one from this, one from this. Or one from this, one from this. That means say we have only 3 choices. Yeah, we multiply them, then we find the sum of them. Okay? Here, if we pick an item here, and if we pick an item from the juices, what we get? Here we have 3 types. To pick an item from the cereal, we have 3 ways. We have 3 ways to pick an item from the cereal, from this one. Because here we have 3 types of cereal. That means if we pick an item from the cereal, we have 3 ways. And if we pick an item from the juices, we have 4 ways, because we have 4 types of juices. And also, if we pick one type of breads, it means we have 6 ways. Later, cereal, 4 juices و 6 bread جو bread معه. على شكل دوانيان هالجيرة لدو جروبي جواز. We cannot choose both items from the same group. I mean, we cannot choose both from the cereal, or both from the juices, or both from the breads. We must choose 2 different items from 2 different groups. We have only 3 options. Let's see. It could be 1 cereal plus 1 and 1 juices. And you can also choose 1 cereal and one bread. And also one juice and one bread. Look, we have only three options. We have only three options. It's either one from this and one from that, or one from this, one from that, and also one from this and one from that. We have only these three options. If we pick an item from three cereals, how many ways do we have? Three. That means if we pick one cereal and if we pick one juice, we have 4 ways. That means it's 3 times 4. That means we have 12 ways. We have 12 ways if we pick one from cereal and one from juices. As you see, it's written here. We say, if we pick an item from cereal and one from juice, it's 3 times 4 is 12. Okay, and let me write down here. Look, one from this is 3 ways. One from this, 4 ways, which is 12. That means if we pick the items from cereal and juices, we get 3 times 4. Because if we pick one among 3, you have 3 ways. And if we pick one from 4 types of juices, we have 4 ways. That means 3 times 4 is 12. And also for juice and breads, for these two, we say if we pick a juice, how many ways do we have? 4, because we have 4 types of juice. And also if we pick one type of bread, how many ways do we have? 6, because we have 6 types of breads. So this is by choosing an item from the juice group, we have 4 ways. And also we have 6 ways if we choose an item from the bread group. 4 times 6 is 24. And what about if we pick an item from the cereal and also an item from the bread? If we pick one from here and one from there. So if we pick an item from the cereal group, how many ways do we have? If we pick an item from 3 of the cereals, how many ways do we have? 3, okay? Because either the first type or the second or the third one. Okay, so here you have 3 ways for choosing or for selecting an item from the cereal, multiplying by. For breads, we have 6 types of breads. If you choose or pick an item from it, how many ways do we have? 6, which is 18. Now we just add the result of each of these. Okay, here if we have a cereal and juice, it's 3 times 4, because here we have 3 types of cereal and 4 types of juice. If we pick one from each, we get 3 times 4, which is 12. And also if we pick a bread and cereal, it's 3 times 6, which is 18, because we have 3 types of cereal and 6 types of breads. Juice and bread is 4 times 6, which is 24. We now add these all. We add all the ways, and we get 12 plus 18 plus 24 is 54 ways. As you see here, we use both multiplication and addition principles in solving a problem. We have another example in this part of the chapter. It says, a 6-person committee composed of Aina, 1, Chan, Tan, Sid, and Hilmi are to be selected to hold as chairperson, secretary, and treasurer. Here we have three positions. We have three positions, and also we have 6 people. 3 of them is going to take these 3 positions. We have six people and 3 positions. It says, in how many ways this can be done? I mean, in how many ways we can give the positions to 3 of them? In how many ways? As you see here, we are going to choose 3 among 6. We are going to choose 3 among 6. That means we are going to choose 3 of them for 3 positions.
For each position, we have to
look. It's reducing. Okay, it's reducing the number of choices. Look, for the first position, we are going to choose 1 among 6 for the chairperson. That's among 6. We are going to choose among 6 people. After choosing the chairperson, so the number of people become 5. Now, for the secretary, we are going to choose among 5. That means we have 5 ways. Okay? And for the treasurer, we have 4 people. See? Because if one of them got a position, he or she couldn't take another position. Each position is for 1 person. So here, it's the same as to choose 3 from 6 things. It's the same. We have 3 positions. Say سه position من هي. لم سه position أمانة لأنه شش كسا سه كسي ها وجيرين بو أم سه position. كواتا بو position يكمل لأنه شك كسر يبجيرين. لأنه شش. position دوم لأنه بينجا. شو يكم جيرات هوا. أما بينج كسا كان. chairperson دياري كده. بس position دوم لأنه بينج كسر يبجيرين. بو position سيم لأنه شو كسر. ليك داني معناه بيتشي. Because this is successive, we have 3 successive tasks, so that's why we use multiplication. And for the first one, for the first question, it says, in how many ways this can be done? That means in how many ways we can choose 3 of them for the 3 positions. Yeah, we say, select the chairperson among 6 people. That means we have 6 ways. And then select the secretary. We have 5 ways because one of them became the chairperson. And select the treasurer. We have 4 ways because 2 of them became chairperson and secretary. So now we just multiply these. So the total ways we have 6 times 5 times 4 is 120 ways. This is 120 ways. That means we have 120 ways to choose 3 people among 6 people for 3 positions. The second question, the questions are written here, even in above, it's written here. In how many ways this can be done? If either Aina or one must be the chairperson. That means we are going to select the chairperson among 2 people. We have only 2 people which could be the chairperson, which are Aina and one. It says, in how many ways this can be done? If either Aina or one must be the chairperson. That means we are going to select the chairperson among 2 people. So for selecting the chairperson here, we have 2 ways because we choose it from 2 people. We select it from 2 people. Then how many more do we have? 5. because we choose the chairperson. Then for the secretary, we have 5 ways. We have 5 ways. So here we have 5, and for treasurer we have 4 ways. So you get 2 times 5 times 4. This is the result. Yeah, it could be done by 2 ways actually. Here we select the chairperson. We have 2 ways for selecting the chairperson because we choose from 2 people. As it says, one or Aina must be the chairperson. That means the only one who could be the chairperson is either Aina or one. No one else could be the chairperson. That means we can select the chairperson among only 2 people. So you have 2 ways for selecting the chairperson. That's why you say you have 2 ways. And then let's say Aina become the chairperson. One could be could get other positions. That means now we have 5 people. We have 5 people for the secretary. So we choose the secretary among 5 people. That means we have 5 ways. And after taking these 2 positions from 2 of them, so what's the how many people do we have now? We have 4. So we choose the treasurer among 4 people. That means we have 4 ways. So here we just multiply these ways to get the total ways. For the third one, it says in how many ways this can be done. If said must hold one of the positions. Just a moment. Look, Sid could be one, or could take one of the positions. That means here we have 3 yes. For the first one, for Sid, we have 3 choices. You either become chairperson, secretary, or treasurer. Okay. Look. So assign said for any position, we have 3 ways. We have 3 ways for said, okay, to get one of the positions because we have 3 positions. Then fill the highest remaining position. We have 5 ways. We have 5 ways. For example, if said become the chairperson. For the secretary, how many ways do we have? Because here we have 5 people. We have 5 people. We choose one of them. See? Because it took one of the positions. In the first step, يكي لو أنا position ورا جريت one ما أبى chairperson. أكرب بيبقى secretary. نعم. Vale. Look, it talks about all. You look at the question. And the question says we have 3 positions and 6 people. It says in how, look at the first question. It says in how many ways this can be done. It means in how many ways we can select a person for each position. For chairperson, for secretary, and for treasurer. For the answer for the first question is, as you see, for the chairperson, in how many people we are going to choose one for the chairperson? 6. So we have 6 ways. And then for secretary, we have 5 because one of them become the secretary. That's why it became 5. So one of them became the chairperson. That means now we have 5 people. It's reduced by 1. So here we have 5. And then 4. Okay, that's it. And in this question, in question 3, it says in how many ways this can be done? How can we fill these 3 positions by those 6 people? If say must hold one of the position. If said must hold one of the position. That means, yeah, we have three options for said. As either chairperson, secretary, or treasurer. That means, yeah, for the first one, that's it. For assign, say for any position, we have three ways. That means say took one of the positions. So now we have 5 people. We have 5 people and 2 positions. We have 5 people and 2 positions because say took one. Now we say fill the highest remaining position. In how many ways do we have? It's 5. We can fill in 5 ways. There, do you get vale? Yes. Look, for the first position, we have 5 ways. We have 5 ways. When we choose someone for that position, how many people do we have now? 4. So for the last one, we have 4 options. We have 4 choices. That's why. سيكيما أجشش كسبين أبي بنمنا. يجي كان لعبة بس chairperson. شنو معه ولا؟ ها ليه لما؟ نفر يجي لاعب بس secretary. شنو معه؟ شوار. دوالي ناو شوار أبو treasurer قالب شيء. وايا بس position جوازه. وهذا هر کسی که حال بشه با position. نه که با position یکش حال بشه. حتی نه حال کنه من نه کس دیاری کرد. اینه که حال بشه جواب. Okay. So here we have 3 options for said. That means we have 3 ways, and then the rest of people as 5 people. So for the next position, we have 5 ways. For the last position, we have 4 ways. We multiply 3 by 5 by 4, we get 60 ways. You either can solve it by this way or this way. Both are the same. In both, you get the same results. And for the last question, it says, in how many ways this can be done? If Tan and Hilmi must hold any position, they must hold any position. Okay? Here we have 2 people that they get 2 of the positions. That means 2 positions are for these 2 people. Yes. Different position. No, there's no 2 people for the same position. Okay. Look, to select the chairperson, secretary, and treasurer with Tan and Hilmi must hold any position. That means Tan and Hilmi will take 2 of these positions. Look, for Tan, let's say for Tan, how many options do we have? 3. And then for Hilmi, how many do we have? It's 2, because Tan took one of them. May someone else say, for Hilmi, we have 3 options, and then for Tan, you have 2. It's the same. You get the same result. Okay? Here, we say assign a position to Tan. We have 3 ways. And a position to Hilmi, we have 2 ways, because we have 3 positions and 2 people. If this one take one of them, so how many more options do we have for this one? We have either this or that one. That means we have 2 options for the second one. For the first people, you have 2 people and 3 positions. Okay? These 2 must take 2 of the positions. For the first of them, it's going to take one of the positions among 3 positions. That means we have 3 ways. And the second We have two ways. So how many more people do we have? 4. We have 4 more people because 2 of them took positions. Okay. Sorry. You have only one position. What's remaining? It's 4 among 4. You have 4 people because Tan and Helmi took their positions. So, vale? Emma Dukas man here, say position share. I'm Dukas, I will do position better. I check position a minute. Yeah. I'm position. Chankas who am I that could position. Chwarkas. Okay, so you have 4 ways. You have 4 ways for the remaining position. We multiply them 3 times 2, 6 times 4 is 24. That means we have 24. We have 24 ways if Tan and Helmi took two positions. Do you have any question about this example? It's really easy. Just don't be confused. It's so easy for solve. Okay. We now have chapter 3, part 2. We finished part 1. We now have part 2. It's about permutation and combination. Have you studied this before? Permutation and combination. Okay. For permutation and combination, we say the difference between permutation and combination. For permutation, we care about order. Okay. We care about ordering, but for combination, we don't care about it. Yeah. The difference between combinations and permutation is ordering. With permutations, we care about order of the elements. As for permutation. And for combinations, we don't. It's the difference between combination and permutation. For example, my fruit salad is a combination of apples, grapes, and bananas. We don't care about one of them is first. Which of them is first? Grapes is first, apples is first, or bananas is first. We don't care about it. We say we have 3 types of fruits. Okay, apples, grapes, and bananas. This is combination. This is combination because order of fruits doesn't matter. But here the combination of local number was 5, 6, 4, 7. Here, if we use 4, 7, 5, 6, it's false. It's not correct. So it must be in the same order. 5, 6, 4, 7. If we change the order, we get false. That's why we say here we care about the ordering of the elements. So it must be in the order 5 first, then 6, then 4, and then 7. So any other order is not acceptable. So it must be exactly 5, 6, 4, 7 for this local number. And here we use permutation. Here we use permutation. That means for any problem that we should care about the ordering, we must use permutation. And for those that we don't care about the ordering, we use combination. If the order doesn't matter, is combination. Combination means selection of things. Combination means selection of things. We select things without caring about ordering it. The word selection is used when the order of things has no importance. So if the order does matter, it is a permutation. Permutation means arrangement of things. It's arrangement of things. The word arrangement is used if the order of things is considered. If the order of things is considered, we say that's arrangement. An arrangement is combination, permutation. So that's the difference between permutation and combination. First, we talk about permutations, and then we talk about combination. Here, for permutations, there are basically two types of permutation. No repetition, and if repetition is allowed. If the repetition is not allowed, and also if repetition is allowed. For no repetition, we say, for example, the first three people in the running race. In a running race, the first one couldn't be the second also. That means here we have no repetition. We have no repetition in this example. Look, in running race, only one person could be the first. And that person couldn't be the second also. That means here, for the first position, for the first one, we have only one person. For the second, we have one person. For the third, we have one person. All of these are different. You have three different people for the first, second, and third. That's why here, we don't have repetition. We don't have repetition. And here, for example, for creating the password or lock of something, lock number of something. Here, we could use repeated numbers or letters, okay? And here, for example, here we have this locker. We have only 3 items. The 3 items could be 333. Is it? It could be 4, let's say 2. We have repetition here also. So here, repetition is allowed. And this example. Here we have some examples about permutations with no repetition. In this case, if we have permutations and no repetition, look. Here we talked about the part of this chapter, and we said we have only permutation and combination. And even permutation, in permutation, we have 2 types. No repetition and if repetition is allowed. Okay? In this case, if we have no repetition with permutation, in this case, you have to reduce the number of available choices each time. This is what we talked about before in choosing the chairperson, secretary, and treasurer. When we said after choosing any of them to a position, the number of people is reduced by 1. Okay? Here we have an example. What order could 16 pool balls be in if no repetition? If no repetition allowed. Okay, here we have 16 pool balls. In how many ways we can order them? Okay, so the first one is among 16. That means for the first one, for the first pool ball which gets in, we have 16 ways because it's either first, second, third, up to 16th ball. It's one of them. So now we have, that means we have 16 ways. We have 16 ways for the first one. They're multiplying because we have successive tasks. For the second, since the first one's in, that means now we have 15. Is it? We have 15 now. Multiplying by. Then we have 14. That's for all. It says for all balls. And the result is 20 trillions 922 billion 789 million 888,000. That is the number of ways that you could in these pool balls, that the pool balls can be in. Okay, we just multiply them. It's about the above example. It says, but maybe you don't want to choose them all. That means if you choose only 3 of the balls. So it becomes 16 times 15 times 14. That's all. Because here we choose the first one among 16 and the second among 14, sorry, 15, and the third one among 14. That means we say 16 times 15 times 14. Okay, this is when if we choose only 3 of them. If we choose 3 among 16 without repetition, if we have no repetition, but if we have repetition, that means we choose each among 16. So you get 16 times 16 times 16 in that case. But here we have no repetition. That means by taking any of them, the total number of things is reduced by 1. So here we say 16 times 15 times 14 was 3,360. Okay, let's take a break for 10 minutes, okay? Here we say, how do we write the permutations mathematically? We use the factorial. We use the factorial function for write down the permutations. The factorial function symbol is this symbol. It is an exclamation mark. Just means to multiply a series of decreasing natural numbers. For example, when we say 4 factorial, it means 4 times 3 times 2 times 1 was 24. And for 7 factorial is 7 times 6 times 5 times 4 times 3 times 2 up to 1. Okay, that means n factorial is the multiplication of n with the numbers before itself up to 1. That means here we say 20 factorial, it equals 20 times 19 times up to 1. Okay, that's for n factorial. It's the multiplication of 1 up to n. And here 1 factorial is 1. How about 0 factorial? It's still 1. It's still 1. Okay, 0 factorial is 1. So if you wanted to select all of the billiard balls, the permutation would be this 6 factorial, 16 factorial. Look, in the previous example, we said you have 16 billiard balls, pool balls. If we want to select all the balls, that means you have 16 balls. If you select all one by one in successive ways, that means you have 16 factorial. As we said before, it's 16 times 15 times 14. As you see, we said it's 16 times 15 times 14 times up to times 2 times 1. This is the same as to say 16 factorial, because 16 factorial is multiplication of 1 to 16. So we can say for all the billiard balls, if you want to select all, we say it's 16 factorial. We have summary. We say a permutation of n distinct elements, x1, x2, x3 up to xn, is an ordering of the n elements x1 up to xn. Okay, as permutation is ordering elements. There are n factorial permutations of n elements. So P of n is n factorial. For example, choosing 10 people among 10 people. That means it is 10 times 9 times 8 up to 1. And this equals to what? It's 10 factorial. Okay, that means, for example, see on the example, choosing 4 people among 4. Choosing 4 people among 4 people. That means you have 4 factorial because we choose all. By choosing all from a group, it means how many elements do you have in the group? Let's say n, it means it's n factorial ways. Look, here we have an example. It says, how many permutations of 3 elements? We have 3 elements. How many permutations do we have? In how many ways we can choose them? It says 3 factorial. Okay, this 3 factorial, 6. Exactly. Let's say we have A, B, and C. In how many ways we can order them? 1, 2, 3, 4, 5, 6. So we can order them in 6 ways. Or you can say it's 3 factorial. Okay, so the permutation of n elements is n factorial. And here we have the permutation of 3 elements, which is 3 factorial. It is 3 times 2 times 1, which is 6. Okay. And here we have another example. It says, in how many permutations of letters A, B, C, D, E, and F contain the substring D, E, F? Here we have A, B, C, D, E, F. It says, in how many permutations of letters, how many permutations do you have for these letters? F, D, E, and F always together. That means here we have, here we deal with this one as only one word. We deal with this one as only one word. It's another one. It's a second letter. It's third, that's fourth letter. Here we have 4 letters. D, E, and F, let's say that's only one letter. Because it says this if we have this string, that means D, E, and F must always be together. We deal with that as only one letter. Let's say it's G. We have G, A, B, and C. That means here we have 4 elements. We have 4 elements. So how many permutations do you have for 4 elements? It's 4 factorial. We say the permutations of n elements is n factorial. Here we have 1, 2, 3, 4 elements. We have 4 elements. That means the permutation of 4 elements is 4 factorial. That's 4 times 3 times 2 times 1, which is 24. Okay. We have another example. It says, how many permutations of letters A, B, C, D, E, and F contain the substring D, E, F together in any order? That means here, for D, E, F, it could be D, E, F. It could be F, E, D. It could be E, F, D, and so on. Okay, so it could be in any order. We have 3 elements for this one, and it says it could be in any order, but they must always to be together. D and E and F must always be together in any order. We say here we have this example, and it says in how many permutations of letters A, B, C, D, E, F contain the substring D, E, and F. We say in the permutations, we must have D, E, F in any order. That means D, E, F in order means it could be F, E, D, E, F, D, E, D, F, like this. Okay, we have 6 permutations here. We say these 3 letters must always be together in any order. Here we have permutation for this one, for D, E, and F. How many permutations do we have? How many permutation for D, E, F do we have? It's 3 elements. We have 3 elements here. In this one, we have 3 elements. So how many permutations for 3 elements? We say it's n factorial. As we have 3 elements, it is 3 factorial. So the permutations for this one is 3 factorial. It's 6. And so how about all? We have 1, 2, 3, 4. 4 elements. So it's 4 factorial. It means it's 3 factorial times 4 factorial. It's 4 factorials. Multiplying them is 144. As you see here, the permutation for D, E, and F, we say it could be in any order. In any order means D, E, and F, we have 3 elements here. So the permutation of 3 elements is 3 factorial, which is 6. And the permutation of D, E, F, A, B, and C, this permutation is 4 factorial because here we have 4 elements. Here we deal with D, E, F as only 1 letter. A is a letter, B is a letter, and C is a letter. You have 4 letters. Oh, it means we have 4 elements. The permutation of 4 elements is 4 factorial, which is 24. But here for D, E, and F, we have a permutation which is 6, which is 3 factorial, and the permutation for D, E, and F is 6. We say 6 times 24 is 144. That means we have, so the permutation for this example is 144. Now we have our permutations. Our permutations, up to now, we just talk about those without repeating. Okay, without repeating the elements. Repetition is not allowed up to now. Still, we talk about no repetition or without repetition. Here we say n are permutations of n distinct elements. It's an ordering R element subset of x1, x2 up to xn. That means here we choose R elements from n elements, n distinct elements. So it means it's R permutations of n, and it's written like this. P and an R. This is all. This is choose one. So this is the number of all elements, and this is the number of choose elements. Those that we choose. For example, we say choosing three people among 10 people. 3 is R. 3 is R, and 10 is N. It's all elements. The number of all elements. Here we say the number of R permutations of a set n distinct elements is this. Look, it could be written by this way, it could be written by this way, and it's all equal to this. That means R permutations of n elements, R permutations of n elements is n factorial dividing by n minus R factorial. For example, if we say choosing 3 people among 5 people, that means here n is the total, which is 5, and R is the choose ones, which is 3. We say P 5 and 3 equals to what? Equals to n factorial, which is 5 factorial. You must memorize this rule. Okay, it's n factorial of n minus R factorial. It's n factorial dividing by n minus R, which is 5 minus 3 factorial. 5 minus 3 factorial. It equals to what? 5 factorial dividing by 2 factorial. Okay, and it equals 5 times 4 times 3 times 2 times 1, and the denominator is 2 times 1. 2 times 1 and 2 times 1 are cancelled out, so it's left 5 times 4 times 3, which is 60. That means we have 60. Okay, so the permutation of 3 permutations of 5 is 60. Here we have some examples, but you should memorize this one. You should know this rule. So the R permutation of n, which is written like this one, P of n and R. The bigger one is n, and the smaller one is R. Okay, as always, R is less than or equal to n. They could be equal. It's okay. For example, permutation 5 of 5. It's okay. It could be equal. We say 5 factorial dividing by 5 minus 5 factorial. We say n minus R. N and R are both 5. And we say it equals 5 factorial dividing by 0 factorial. And we said 0 factorial is 1, which is 5 factorial over 1 and 5 factorial, which is 120. Okay, 5 times 4 times 3 times 2 times 1 is 120. So this is if R and n are equal. So R is always less than or equal to n. Here we have no such an example to be, let's say, P of 3, 5. That's not correct, because this is the position of n, and this is R. R must not be greater than n. Okay, this is impossible because we cannot choose 5 people among 3 people. We cannot do that. Okay. Now return to the billiard example, billiard balls example. If you want to select just three, then you have to stop multiplying after 4, as you see here. If we just select 3, that means P 16 and 3, P and R. Okay, so what's P of 16 and 3? It is n factorial, which is 16 factorial, dividing by 16 minus 3 factorial, and equals 16 factorial dividing by 13 factorial. It equals 16 multiplying by 14 multiplying by 15. Multiplying by 13, multiplying by up to 1. And the denominator is 13 multiplying by 12, multiplying by 11, multiplying by up to 1. These all are cancelled with these. Okay, so what's left? We have only 16 multiplying by 15 multiplying by 14 equals to 3,360. This is the result. Okay, that's it. As you see, 16 factorial dividing by 16 minus 3 factorial, or 16 factorial over 13 factorial. That's 3,360. Look, it says in how many ways can first and second place be awarded to 10 people? That means you have 10 people. We have 10 people. We just select the first and second place among 10. For the first place, we choose among 10. For the second, we choose among 9. But if you use permutations, here n equals 10 and r equals 2. We have only 2 positions, 2 places. We just take 2 places. Okay, first and second. R is 2. That means P of n and r equals P of 10 and 2, which is 10 factorial dividing by 10 minus 2 factorial, which is 10 factorial dividing by 8 factorial. And we can say the numerator is 10 times 9 times 8 factorial. Can you say that? This circumstance. You can't just leave like this. Do not expand it. So here we get 10 times 9 is 90. That means we have 90 ways. We can do it in 90 ways. Okay, you even can expand it and then divide it. How many 2 permutations of 3 elements? How many 2 permutations of 3 elements? That means here R is 2, N is 3. So you say it is P of 3 and 2 is 3 factorial divided by 3 minus 2 factorial. That's 3 factorial of 1 factorial, and 1 factorial is still 1. We get 3 factorial, which is 3 times 2 times 1 and 6. Sometimes we don't write down this one because it's the same result. If we multiply it by 1 or not, it's the same result. Here, it's not multiplied by 1. So that's it. There's 6 ways. So 2 permutations of 3 is 6. It says, in how many ways can you select a chairperson, vice chairperson, secretary, and treasurer from a group of 10 persons? That means here we have N is 10, R is, we have 4 positions. Yeah, N is 10, R is 4. So you just find P of 10 and 4, which is 10 factorial dividing by 6 factorial, is it? And equals as 10 multiplying by 9, multiplying by 8, multiplying by 7. Is it? Because it's multiplying by 6 factorial. This will cancel with the denominator. That's why you don't write down it. Okay? اگر جێری کردەکە هەرچی چەند فاکتۆریال بوو سەرەی کردەکە تا ئێوە بوون کورد دەبێتەوە یەکسەر. For example, if you have, let's say, 8 factorial dividing by 7 factorial. So what's the result? It's only 8. Yeah, just 8. Okay, because it's 8 multiplying by 7 factorial. This will cancel out the denominator. Okay. These will cancel out. So we just get 8. So how about if we have 8 factorial over, let's say, 5 factorial equals to what? 8, yeah, 8 multiplying by 7 multiplying by 6. That's all. And so on for others. That's for reducing, I mean, for saving time. That's for yourself. Now have another example that says in how many dance pairs can be formed from a group of 6 women and 10 men. We now have 6 women and 10 men. Okay, we should find the number of ways to make the dance pairs from a man and woman together. Okay, dance pairs means a pair of woman or man, where W stands for women, and M is for man. Here we have 10 men and 6 women. Okay, so the number of women is less than the number of men. The number of women is less than the number of men. And here we just can choose 6 pairs. That's it. We just can choose 6 pairs because here we have 6 women. We have 6 women. That's why we just choose 6 pairs. one man and 1 man and 1 woman. Here we say the number of men is 10. That means we say we choose 6 men. We choose 6 men among 10 men because here we have 6 women. ليرة شش عفرت ما هي دبيا ما هي. لبري عفرتيان شش هم أصلنا إن دانسة كوا. بلان بيا كان شن يعني توان شش يعني. لأنه شن هم شش الله بجد. That. So that's why we say N is 10 and R is 6. That's why here you say n factorial divided by n minus 6 factorial, n minus r factorial, and we get this. So we have 115,200 ways for doing this. Okay, is that easy? In how many ways can 6 boys and 5 girls stand in a line so that no 2 girls are next to each other? No 2 girls are next to each other. Look, as we have 6 boys and 5 girls. Look, let's say this is boy. We should order them on a line. 2, 3, 4. 4, 5, 6. Okay, so how many girls do we have? We have 5. How can we put the girls? One of them could be here. 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 And one of them could be here. And also one of them could be here. It's okay if 2 boys after each other. Okay, but we must have no 2 girls next to each other. How many positions or places do you have for 5 girls? 7. 1, 2, 3, 4, 5, 6, 7. We have 7 places to put 5 girls in. Okay, so we say, let me write down them. We have 7 places to put 5 girls in. This is a place for a girl. That's place for a girl. That's. We have these 7 places for the girls, but we have only those 6 fixed places for the boys. That means for the boys, we have permutation of 6 and 6. We have 6 places for 6 people. Okay, we get 6 factorial dividing by 0 factorial. Is it? 6 minus 6 is 0 factorial. Because here R is 6 and N is 6 also. That's why which is 6 minus 6 factorial, which is 6 factorial. This is permutation of 6 of 6. That's for the boys. For the girls, how many places do we have? 7. And how many girls do we have? 5. We have 5 girls. As you see, it's written 5 girls. We have 5 girls. That means permutation of what?
7.
Yeah, 7 and 5. That is 7 factorial divided by 2 factorial. Is it? So it equals 7 multiplying by 6 multiplying by 5 multiplying by 4 multiplying by 3. Yeah. And this is 6 up to 1. And here permutation of 6 of 6 is 720. And permutation of 7 of 5, that's for the girls. And that's for the boys. As 2520. Then we multiply these two, this multiplication. We multiply these two. We multiply 720 by 2520 and you get 180. So that's 1,814,400. This is the result. Okay, so now here we are going to find the permutation of 6 boys for 6 positions, 6 places. And also we are going to find, but here you should know how many positions do we have for the girls. We have 7 positions for the girls. Okay, since you have 7 positions for the girls, that means we are going to put 5 girls into 7 places. We choose each place for a girl. That means we have permutation of we have 5 permutation of 7. That means P of 7 and 5. So if the repetition is allowed, okay, it's enough for today. Okay, we get here to repetition to be allowed.